Process flow charting is a way that you can depict what a process looks like. You use rectangles for tasks, triangles for storage areas, diamonds for a decision point, and arrows for flow of materials or customers. I have here an example of hamburgers being made at Burger King. You have the raw materials, which would be the uncooked beef, the bread, the cheese, etc. It flows to get cooked. It is then cooked, and it is staged at a work in progress point. At this point, the timeline continues a little bit, and what happens is you have, if you see down here, a little assembly for a standard product, and it's a finished good that's in the staging area. Okay, at this point, there will be a decision made by the customer right here. Customer places order. It goes to custom or standard. If it's a custom delivery, it will be handled different than standard. It's a standard, it's a finished goods. It will just move on to the delivery to the consumer. If the custom decision is made, it is then built, assembled according to that order, and then delivered to the customer. So as you can see, it's a way that you can depict what the process looks like for any given process in business. Theory of constraints. Theory of constraints is a lot, it takes into consideration a lot of, what we've been talking about, continuous improvement. Basically, it is a 5-step process that is ongoing to remove as many of the constraints as possible to further the goal of the company, which would be to, make money. So, okay, what's the 5-step process? 1, identify the constraint, whatever is holding you back. What one thing is slowing down all the production here? 2, decide how to exploit that constraint. 3, align all other processes to this. 4, elevate the constraint. 5, if the constraint has moved, return to step 1, i.e. it's an ongoing process. Okay, talked about that. This takes into consideration that there's always some constraint, so it's ongoing improvement. So in other words here, the constraint, the bottleneck would be considered the constraint usually. The bottleneck sets the tempo for production, and we use the phrase drum buffer rope. So what that means is that the bottleneck is the drum, because it sets the tempo. It should have some amount of buffer, and when we talk about JIT just in time, it kind of goes against that idea, but by having a buffer, if something does go wrong, at least that constraint can work continuously and not interrupt production, and you can make up time a little easier further up the line. Okay, so a little bit of buffer, rope, because what it is it's pulling, the constraint is what's pulling the rest of the supply chain, so it talks to the rest of the chain up ahead. This is what I need to continue on with my production. Theory of constraints. 6 Sigma, quality. This is concerned with limiting variations of production to half the natural variation of factory output. Okay, so the basic idea here is, if you look on here, there's a bell curve here. It's a natural curve. 3 standard deviations away is what your spec limits would be, say for example. Okay, by implementing your 6 Sigma program, what you want to do is you want to cut the variations to half of that. So then you would have a much more narrow bell curve. Your normal product would be right here. Okay, your 3 standard deviations would be well within the spec limits of what you're producing, and that what the previous spec limits were set as would then be considered 6 standard deviations from where you are. So what that means is that your variations will be a lot more rare, and you would have a lot more quality built into your production system. Again, it's an ongoing improvement, so you need to consider that. The Six Sigma program was started in Motorola back in the early 80s. It has an educational background to it where you can be certified as a black belt or a green belt, or they use belts to signify where you are in the educational process. And it has to do with define, measuring, analyzing, improving, and control. Lean production systems were really brought in by Toyota. The lean system, again, goes to this whole continuous improvement in pulling. It says, a pull-based production system designed to produce at high volumes while minimizing inventories at all stages of production. Again, you get your stuff right in time. You're not paying for storage. You're not wasting time by building up resources too fast in some areas and slowing down in the others. Okay, so Fujio Cho was working with Toyota in developing this program. His views on elimination of waste basically go as follows. There's 7 of them here. Focused factory networks, group technology, quality at the source, just-in-time production, uniform plant loading, Kanban production systems, and minimized setup times. If you adhere to those principles, you will minimize your waste. The Kanban production system basically uses a notification. It could be some signal. It is some signal, but it could vary how you use it. But basically, it's a notification that a certain number of parts will be needed for continuing production. So different signals are used, maybe a light, maybe a card or something like that, to notify, to notify upline what parts are going to be needed to continue the production. Just to comment before I go on to the next slide, going in line with that lean production and quality, if at any point during the assembly line, if there's a problem, it puts responsibility on the employees to either stop the line or to work out the problem before it continues. Okay, so one thing that's important here is that each person is going to be responsible to be their own quality control engineer to make sure that their job is done right.